crashed again. But I wanted to go over the intermolecular forces so you know which one is the weakest versus strongest. So start doing this. Dispersion, everything has dispersion forces. If you have protons and electrons, which everything does, then you have dispersion. And these are actually the weakest. Now they can get stronger as a molecule gets bigger because it has more electrons and protons. And branching versus non-branching. So you can make them get stronger, but they're still going to be the weakest. The next one is dipole. The dipole. These are going to be between your electronegative atoms. This is a kind of like a magnet. These are pretty strong. The strongest are going to be your hydrogen bond. These are actually just a dipole interaction. Strongest, but a very, very strong one. The hydrogen bonds they're going to be between oxygen, hydrogen, nitrogen, and then fluorine. Which, speaking of, if we go to the next question really quick, you had trouble with the hydrogen bond here. So here's the problem. Here's what you missed. So a hydrogen bond has to always be between hydrogen, oxygen, nitrogen, or fluorine. So do you see these three things here? So do you see always in the middle here you have a hydrogen. Now on both sides you have to have either an oxygen, nitrogen, or fluorine. On this one you have an oxygen and nitrogen. So this is a hydrogen bond. Hydrogen, that technically is a real bond to hydrogen, but it's not considered the intermolecular force, which we call a hydrogen bond. So it's kind of deceiving. So this is not a hydrogen bond because there's not an oxygen, nitrogen, or fluorine on both sides. Here, this hydrogen is bonded to fluorine, but on the other side is trying to interact with carbon, which is not one of the strong electronegative atoms that cause a hydrogen bond. Over here, it's trying to hydrogen bond with this oxygen, but since it's bonded to this carbon, it will not hydrogen bond. Okay, so it has to be, you see on both sides here, this is the best example. It's a oxygen, it's a hydrogen bonded to an oxygen, nitrogen, fluorine, trying to interact with an oxygen, nitrogen, fluorine. So I hope that helps.